What is the evilest type of chemical you can think of? Would it be nitriles, contains dangerous poison CN, or water, dissolves nearly everything, or the notorious acids? Just for this month's video, we're going to focus on acids. What's your mental picture of an acid? A drop of smoking liquid burning its way into a piece of iron? A green substance that is held in a beaker labeled with a skull and crossbones? Well, when you live in the atomic world, acids blend in very well. Unless they're infamous, you can't even see whether they're an acid, or you can mostly when they're not. Here, we're focusing on a specific type of acid called an Arrhenius acid. This type of acid releases protons and forms an ionic salt. And indeed, table salt is also an ionic salt. We can disassemble the term to find the word ion, which means a charged molecule or atom floating around by itself. An ionic salt is formed by two ions bonding. For example, KCl is a substitute for salt made from bonding K plus and Cl minus. You might ask, why do acids work? Arrhenius acids normally work in water. That's called an aqueous chemical. It's abbreviated using AQ. They also use proton carriers for transferring hydrogen atoms. In this case, water is a proton carrier. Let's look at a specific reaction. This looks simple, but there are additional steps to this equation. In the aqueous solution, the proton HCl gave up was immediately transferred to the water. Then, the water gets rid of the proton and gives it to the negatively charged OH. Sodium separates with now water molecule, and it joins with the chloride ion to form dissolved table salt. That sounds very well like a tongue twister. If you're still confused, I can make a small model for you. One thing you should be wondering is how in the world the hydrogen proton managed to escape from the highly electronegative or strongly attracting electrons chlorine ion. It turns out that water has very differing attracting strength to electrons. Electrons are a lot more attracted to oxygen than the hydrogens. This is the definition polar. Since hydrogen is so attracted to oxygen and chlorine is so attracted to the hydrogens, the bonds stretch until the link snaps, leaving a proton attached to the water molecule and a poor ion that isn't strong enough to snatch hydrogens from the oxygen. Then, the oxygen has a positive charge and decides to get rid of the hydrogen sticking to it. Since the reverse reaction would happen if he gave it back to chlorine, hey, what's that? A highly negative OH group sticking out of sodium's book? Good. The hydrogen forms a bond with the hydroxide, OH group, and has the new water molecule expel sodium, which find chloride ions and become table salt. This type of reaction is called a neutralization reaction because it neutralizes both the acid and the base. On the other hand, does acid work on everything? No! If the result molecule does not want to get any protons, then the acids are useless because the water would give the proton back to them. So what is the special property of sodium hydroxide that gives them the ability to interact with acids? Of course, the OH minus or hydroxide. The definition of an Arrhenius base is a compound that produces OH, and so all chemicals, including a hydroxide group, are considered bases. Something you also might want to learn how to name acids and bases. This time, I will need you to remember several names and rules. I'm actually terrible at this part, so maybe do a better job than me. First, a rule for naming oxygen anions, or ions containing oxygen. Oxygen anions are negatively charged, courtesy of the several oxygen atoms holding in electrons. The standard amount of oxygen atoms is called 8. For example, NO3 is called nitrogen 8. So 3 is the standard oxygen number of nitrogens. Remove one oxygen and it is now called ite. NO2 is one less oxygen atom than the standard, so it is called nitrite. One less again, and it's called hyponitrite. There's also a less commonly used pre or suffix, and it's one more oxygen than the standard. NO4 is called pernitrate. A one-atom anion also has its own suffix, "ide." For example, sulfide ion is S2-, chloride Cl-, and so on and so forth. Also note that the charges don't change in relation to the number of oxygen atoms. How does this help? Acids also have their own pre-suffixes, and those are based on the 8s and 8s you just learned. To be sure, here's a quick quiz. 1. Name chlorate's molecular formula. 2. Name the anion CO4. For our purposes, please use the 8s and 8s. 3. What is fluoride? If you're ready to move on, let's go and name these acids. Yes, Arcturian, bring those name tags. We're going to use them. The simplest type of acid to name are the hydro acids. When the anion ends with an "ide," we just stick hydro to the front and "ic" to the back, like HF, which is hydrofluoric acid, or HCl, hydrochloric acid. However, it is important that you stick on as many hydrogen atoms as needed. HS is not hydrosulfuric acid. There's also an atom that doesn't abide by the rules. Nitrogen seemingly forms hydronitric acid, but if you look at the formula, that's basically ammonia. The 8s make a class of ic acids. For example, chloric acid is made of enough H to balance the charge. In this case, 1, and 1 chlorate ion. The formula of chloric acid is HClO3. As a practice, what is the formula of sulfuric acid? It is the compound made from sulfate and hydrogen. Sulfate, SO4 2-, has 2 negative charges and takes 2 hydrogen atoms to balance. Sulfuric acid is, of course, H2SO4. Well, what does sulfite make? Sulfite collaborates with hydrogen to make sulfurous acid. Sulfurous acid has formula H2SO3. This is the main part of naming acids. For hypoites and perites, keep the prefix and change the suffix according to the rules listed above. The things I have talked about on my channel are quite important, so check out my channel's posts and try to answer the questions there. As final treat, let's look at an animation of acetic acid neutralizing sodium hydroxide. Enjoy!